Hey guys, it's Eddie the Magic Monk. In this lesson, I'm going to explain to you the present value of annuities. So I want you to imagine that there is a box. There is a box full of money, okay, full of money. How do you draw money? Very bad drawings, but let's say there's a box full of money and every time period, whether it be monthly or weekly or whatever time period you decide. So let's say every month we take out a certain amount of money from the money box. So let's say every month we take out $500 from the money box. Now, if you want to look up how much money is in the box, either in the first place or a year from now or 2 years from now, how much money is still left in the box, you use the present value formula to look up how much money is in the box. So that's when you would use the present value. So let's give you guys a quick example of that. Okay, so let's have a read of this question. John wants to borrow some money to buy a car. Each month he is able to repay $240. So what that means is however much he borrows, he's going to pay back the person that he's borrowing $240 every month for 3 years, right? That must be what he can afford from his salary or whatever work that he's doing. If the interest rate is 6.4% per annum, okay, usually the rate is quoted in annum or yearly, means the same thing. Annum and year means the same thing. Compounded monthly. So every month the interest gets calculated and added on. How much can he borrow? So what this is saying is, if we go back to the box situation, okay, whenever you're confused, just draw your money box. Now every month, so this is the loan amount, which we're not sure of what it is. But we know that every month he's going to take out $240. He's going to subtract $240 from the total amount that he's borrowing. $240 per month. He's going to keep taking money out, $240 every month, until there's no money left, and he's going to keep doing that for 3 years. Over 3 years, every month some money is going to come off. So the question is, how much money is in the box in the first place? So in order to calculate this, you want to use a formula. So let's get that formula up for you guys. Okay, so this is the formula for finding the present value of annuity. Now, depending on what textbook you guys use or which lecture notes you guys have, you might see different formulas, but they should all be in the same structure, I would say. So what are these symbols? A is the present value of an annuity, of the annuity that we are talking about. R is the repayment made at the end of each time period. In this case, we are talking about monthly, so let's write that down. Monthly. I is the interest rate per period. In this case, for us, it's month. And the last thing we have is N, which is number of periods. So number of months. So let's find the corresponding values from our question. A is what we want to calculate, so we have no idea what it is. Repayment made at the end of each time period is specified in the question as $240. $240. So let's write that down. R is 240. Okay, now we have interest rate per period. Now, in the question, the interest rate is 6.4% per annum. So let's write that down. 6.4% per annum. Now, we want that in per period, so per month. So how do you go from yearly to monthly? You would divide that by 12. So you would go 6.4% divided by 12 is 0.53 recurring percent, but we also want it as a decimal. Okay, we want it as a decimal in this formula. So then you would divide that by 100, which is 0.005333 and so on, 3 recurring, so you don't have to write all those threes. Now, if you get a number, usually with decimals, with a lot of numbers after the decimal point, usually you would leave your answer as a fraction so that when you type it into the calculator, you don't round it before you get the final answer. So really, mathematically, the best way to write it is to keep it like this. Okay, so I've divided the top number by 100, which gives you 0.064, and then you divide it by 12. So I leave it as a fraction so I don't have to write all those threes on the end. Okay, the number of months, so over 3 years, how many months are there? Right, because the time period is 3 years, but we're dealing with the number of months. So let's go 3 times 12, which is 36 months or 36 periods. So we have now done the whole thing in terms of the number of months. So, it's sort of screwed up a little bit, but hopefully it was working well before for you guys. Okay, so let's try and put all these things into our formula. So we have the interest rate, sorry, not the interest rate, the repayment per month times by 1 minus bracket 1 plus I was 0.064 divided by 12 to the power of negative 36 divided by I, which is again 0.064 divided by 12. So let's just type all of that into the calculator. So I'll show you guys how to type it in. So let's just clear it all. And let's go to 240 times bracket 1 minus bracket 1 plus 0.064 divided by 12, another bracket to the power of to the power of is this button here, negative 36. Now, depending on what calculator you have, the negative button might be different to the minus button. Okay, so all of that is the top line. So press equals, and then I'm going to divide it by the bottom line, which is 0.064 divided by 12. And I have $7,842. 7842.23. Sorry, because I need to round it. Okay, so that is how you do the present value of an annuity. Now, one last thing before I let you guys go is that what we have just done, we have made an assumption, and that is we are making the repayment at the end of each month. So I should say that in the question, at the end of each month. And that's why the annuity, the type of annuity we're dealing with is called an ordinary annuity. Now, if you want to do the repayment at the beginning of each month, then that changes the equation, changes how we calculate things and so on. But typically we assume that the repayment is made at the end of each time period. Okay, thanks for watching, guys. See you next time.